यस।
Yeah, teacher, we had completed till alkali metal is a strong reducing agent, and then उसके बाद you give that formula M plus NH3 gives MNH3N uh, positive ion plus ENH3 3 and negative ion. उधर तक किया था.
ओके। नो, कहाँ तक किया? एल्कली मेटल्स, एल्कलाइन अर्थ मेटल्स किया हमने।
अल्कलाइन अर्थ मेटल शुरू किया था हम लोग, मतलब कंप्लीट किया था. और
ओके।
हम, हाँ हाँ
रिड्यूसिंग नेचर हो गया था ना, मैंने तुमको
हाँ हाँ.
अमोनिएटेड इलेक्ट्रॉन, हाँ ये बताओ ना, अमोनिएटेड इलेक्ट्रॉन्स क्या होता है?
अमोनिएटेड इलेक्ट्रॉन्स ये होता है
लिखो उसका रिएक्शन अलग से, बिना देखे लिख
डी,
के बताओ।
इधर वो, इधर
अमोन
लिखा हुआ है डीप ब्लू कलर सॉल्यूशन पैरामैग्नेटिक लिबरेट्स द गैस, लिबरेट्स
हाँ,
H2 गैस.
या तो और उससे क्या बनाता है वो? मेटल अमाइड।
मेटलामाइड.
क्या? हाँ। तो
मेटलामाइड.
यस, मेटल अमाइड। बेटा अभी जो मैं पढ़ा रही हूँ, एग्जाम कब है तुम्हारी?
केमिस्ट्री आई थिंक 17th.
17th। 17th। तो कल भी लोगे क्लास अभी कि खाली आज ही लोगे? क्योंकि सिलेबस तो तुम्हारा बाकी है कि नेक्स्ट वीक करना है।
नेक्स्ट,
ठीक है।
नेक्स्ट वीक ही कर लेते हैं ना, क्योंकि टाइम है इसलिए.
अरे खत्म कर लेंगे ना तो तुम्हारा रिजल्ट अच्छा आएगा, फिर नेक्स्ट वीक प्रैक्टिस भी हो जाएगी, क्योंकि 17 तो आई। बाकी तुम्हारे पास 3-4 सब्जेक्ट भी तो है करने के लिए। स्टिल यू कैन टॉक टू योर मम्मा एंड मैम को बता देना,
ओके.
ठीक है। हम्म। अभी क्या है?
अच्छा.
अमोनिएटेड इलेक्ट्रॉन्स। अमोनिएटेड इलेक्ट्रॉन्स हैं, दिस इज responsible for blue color of these solutions. Okay, so whenever this metal, ammoniated metal, reacts with ammoniated electron, ये क्या, और इन प्रेजेंस ऑफ अमोनिया, अमोनिया गैस डालेंगे तो ये क्या बना देंगे? ये बना देंगे मेटल अमाइड प्लस हाइड्रोजन। ओके, सो देयरफॉर वी से दैट ये अमोनिएटेड इलेक्ट्रॉन्स जो होते हैं ना, ये देते हैं डीप ब्लू कलर सोल्यूशन। और दूसरा क्या है? अकॉर्डिंग टू केमिस्ट्री, कलर क्यों होता है? कलर होता है बिकॉज ऑफ इलेक्ट्रॉन्स। ओके, उसी तरीके से आप दिखते हो। और ये दूसरा क्या होते हैं? दे आर पैरामैग्नेटिक इन नेचर। दे आर paramagnetic in nature. Similarly, we can see group 2. Group 2 के अंदर में क्या है? See, group 2, it is very similar to alkali metals. So इसको हम बोलते हैं alkaline earth metals. और जो alkaline earth metals होते हैं ना, they are soluble in liquid ammonia. तो इसका मतलब alkali metals and alkaline earth metals, they both are soluble in ammonia. और बेसिकली आप देखते हो कि ये हमको देता है डीप ब्लू ब्लैक कलर्ड सॉल्यूशन। क्या देता है? डीप ब्लू ब्लैक कलर्ड सॉल्यूशन। ओके, now we'll see about the diagonal relationship. See what is diagonal relationship. See, basically, whatever the elements, they belong to same group. They exhibit similarity. So the first alkali metal, that is lithium, and the first alkaline earth metals, beryllium. Okay. They do not fulfill diagonal relationship. बाकी डायगोनल रिलेशनशिप है वो एग्जिस्ट करती है, लेकिन लिथियम और बेरिलियम ये नहीं देते हैं. Thus, lithium shows many difference जो with the remaining alkaline metals, लेकिन lithium है वो शो करता है Mg से. उसी तरीके से बेरिलियम है, it shows many difference with other, but beryllium aluminium इससे शो करता है the second element of the next group. सो इसको हम देखेंगे ना, लिथियम, सोडियम, बेरिलियम, मैग्नीशियम, बोरॉन, एल्युमिनियम. तो ये रिलेशनशिप ऐसी जाती है, डायगनली एग्जिस्ट करती है, इसलिए हम इसको बोलते हैं डायगोनल रिलेशनशिप. ओके. अभी आप देखोगे लिथियम और मैग्नीशियम के अंदर में डायगोनल रिलेशनशिप है. सो लिथियम ये शो करेगा विद, लाइक लिथियम और मैग्नीशियम दोनों जब लिथियम नाइट्राइड और मैग्नीशियम नाइट्राइड बनाते हैं, तो दोनों की प्रॉपर्टी डेलिक्वेसेंट होती है. डेलिक्वेसेंट का मतलब क्या होता है? थोड़ा सॉफ्ट, नॉट एग्जैक्ट पाउडरी. और उसके अलावा आप देखोगे कि ग्रुप 1 एक्सेप्ट लिथियम एंड ग्रुप 2 एक्सेप्ट बेरिलियम, ये लोग क्या शो करते हैं? ये लोग नॉट डेलिक्वेसेंट. ओके. मतलब Li है वो डेलिक्वेसेंट है और Mg है वो डेलिक्वेसेंट है. बाकी ग्रुप 1 ग्रुप 2 है वो रिएक्शन नहीं देते हैं, तो ये उनके बीच में रेजेम्बलेंस होती है. ओके. और दूसरा क्या होता है? नेचर ऑफ बॉन्डिंग. सी, कल हमने पढ़ा था क्या? LiCl ये कोवेलेंट बॉन्ड क्यों देता है? हम्म. Why LiCl is, it has to be ionic but it is covalent. कल किया था ना हमने.
हाँ मैम.
और दूसरा, अगर हम BeCl2 देखते हैं, तो इसके अंदर में
हाँ.
भी क्या है? BeCl2 ये इसके अंदर में भी आप देखोगे कि ऐसा ही नेचर देखने को मिलता है, कोवेलेंट बॉन्डिंग. सो BeCl2 हैज गॉट कोवेलेंट बॉन्डिंग. ओके. एंड बेसिकली इसकी जो ऑक्साइड्स होती हैं, दे आर ऑल एम्फोटेरिक इन नेचर. सो व्हाट आर एम्फोटेरिक ऑक्साइड्स?
Amphoteric oxides are those which
What are amphoteric oxides? Hmm?
no, sir, I don't.
अच्छा, व्हाट आर न्यूट्रल? न्यूट्रल मतलब क्या होता है? जो ना एसिड ना बेस. और
Yeah, so no,
एम्फोटेरिक मतलब होता है विच एक्ट्स एज बोथ एसिड एंड बेस.
both are certain. Oh,
ओके. तो LiCl है, अब उसके बाद में है AlCl3. अब
हाँ.
AlCl3 है, ये तो डाइमर बनाता है.
Yes, teacher.
हम्म. एंड इट इज अगेन एम्फोटेरिक. ठीक है, वी नो वेरी वेल दैट AlCl3 is amphoteric in nature. How you will prove the amphoteric nature? See here, Al2O3 will react with HCl and it forms AlCl3. Okay, plus water
Oh,
AlCl3 plus water. And then this Al2O3, when again reacts with NaOH, what it will form? It will form sodium aluminate. Okay. So, what do we see? That both of them are amphoteric. But whereas if we see group 2, they will always give ionic. And group 13, it is covalent. So you have to study the nature. Got it? So the diagonal relationship between pairs, it shows belonging to different group and period. Is why? It is because of the similarity in atomic properties. Okay. So therefore, atomic and ionic radii, if we check for lithium and magnesium, they are, you can say, very similar. Okay. So see, we have to now study. Now I want you that we have studied so much. Can you check the uses of group 1 and group 2? Just go through this now. Group 1 and group 2 uses, like it is lithium is used in batteries, liquid sodium.
Okay, teacher. Okay.
And potassium chloride is used as fertilizer. Done?
Yeah, teacher.
It is just the uses.
Yeah, done, done.
Okay. So basically, we are seeing now moving on next. Okay, group 1, group 2, biological importance. You should learn because this is your school exam and that will come. Okay. Now see the problem number 8.7. Magnesium strip slowly tarnishes on keeping in air. So, but metallic calcium is readily attacked by air. Why?
Do I say the answer or do I just read it?
No. You have to tell me. You have to use your mind.
Okay. Basically, Mg and Ca, magnesium and calcium are both from the group 2, but they are from periods 2 and 3 respectively. फिर
Hmm.
उसके बाद when they are both left in the open air, they both start to lose their valence electrons. Uh,
Yes, Neil, continue. Magnesium and calcium.
yeah,
Can
sir.
you remember a periodic table?
Yeah, sir. I told they're in group 2, but in period 2 and 3 respectively.
So what happens? See,
Basically, they both start to lose their valence electrons when
uh,
they are left in the open air. But the
mhm,
metallic character is greater in uh, calcium, which goes on increasing down the table.
mhm.
उसके वजह से the उसके वजह से calcium starts to lose more and more electrons, thus getting dissipated much easier than magnesium. Therefore, magnesium takes some time to dissipate completely in the open air, while calcium is readily attacked.
Okay, fine. So we learn this off. Okay. Now we'll see some important compounds. Now again, this you have to learn. Basically, it's about washing soda. Now washing soda Na2CO3 dot 10H2O. This you have to remember. Okay. Now uh, see, basically, sodium carbonate is actually prepared by solvay process. Okay. Now, in this process, carbon dioxide, it is passed into concentrated NaCl and with NH3. Okay. And then what will be the product? Now, here it is saturated, means it is totally added up. So therefore, crystals of sodium bicarbonate that is formed. Now, two things that you have to see here, that sodium bicarbonate, or you can say which is having low solubility. And because low solubility is there, then you can see the crystal precipitate which is formed. Okay. So basically, here the process which is taking place is nothing but the double decomposition. What is taking place? Double decomposition between ammonium bicarbonate and sodium chloride. And then NaHCO3. You can call this as sodium hydrogen carbonate. This dissociates into Na2CO3 plus H2O plus CO2. Okay, so therefore this is nothing but Solvay's process. And how we can recover the ammonia? This NH4Cl is obtained by treating this ammonia can be obtained by treating the solution of ammonium chloride with calcium hydroxide. So we get ammonia gas, and you know this ammonia gas is further used up in making, you can say, a ammonium chloride. Then we can use various like Domex toilet cleaners. There in all these things ammonia gas is used, and even in the making of fertilizer.
Okay.
Hmm? Now potassium carbonate Na2CO3 cannot be prepared by Solvay's process. Why? Because potassium hydrogen carbonate is highly water soluble and it cannot be prepared by reaction with potassium chloride. Okay, now properties. So this sodium carbonate is what? It is washing soda, which we use, जो कपड़े धोने के काम में आता है. Okay, और इसका फॉर्मूला क्या है? Na2CO3.10H2O. और ये ना पानी के अंदर में बहुत soluble है. Okay, and when we heat it, the डेकाहाइड्रेट का मतलब क्या है? जब हम लिखेंगे Na2CO3.10H2O, 10H2O मीन्स डेकाहाइड्रेट. तो इसके अंदर में से वाटर मॉलिक्यूल रिलीज होगा. तो पहला क्या रिलीज होगा? पहला बनेगा वो Na2CO3.H2O प्लस 9H2O. Okay, and then this Na2CO3.H2O है, फिर ये break down होगा into Na2CO3 plus H2O. Got it? So this
Okay.
aqueous solution of sodium carbonate is alkaline. Now, why any solution is alkaline? Any solution is alkaline because of its hydrolysis. That is NHCO3 plus NaOH. So what are the uses? See the alkaline properties of sodium carbonate. They are very important for emulsification. You know, whenever any question is there which is related to emulsification, it basically deals with the fat. So, you know, whatever the dirt, the fat stains which are there, now that can be totally removed and it is used as a cleaning material. Got it? And it is also used to make hard water soft. So it is used as a water softener. Okay, जहां पे hard water होता है वहां पे हम यूज कर सकते हैं. Got it? And therefore, most important thing in the case of hard water is when it is used. So this Na2CO3, it breaks down by adding with calcium hydrogen carbonate. आप इसको ऐड करोगे तो कैल्शियम कार्बोनेट हो जाएगा और NaHCO3 है वो बन जाएगा. And it is also used in the commercial preparation of caustic soda and it is also used as a laboratory reagent. Okay. Now here you have importance of caustic soda. What is caustic soda? In caustic soda, we see that sodium hydroxide First thing, it can be prepared by the process of electrolysis. Okay. Now, electrolysis of aqueous sodium chloride. Now, here what we are using? We are using sodium chloride. So, in this process, chlorine gas is also formed. So, NaCl, the solution of NaCl is called as brine. Okay. And this brine is subjected to electrolysis in Gallner cell. And in this case, the most important electrode which is used, that is mercury, which is used as a cathode. See, in this type of reactions, it is very important for us even to use the proper electrodes. You know why?
No, sir.
See, here, basically, we need to check that the electrodes do not get utilized up. Okay. There are many conditions in which the, electrodes, they get utilized up. So we don't want that. And similarly, here, carbon rod is used as anode. Okay. So therefore, when it reacts, we get, yes, sodium amalgam. Now, why we are getting sodium amalgam? We are getting sodium amalgam because we have used mercury cathode. Are you getting? So, here you will get sodium amalgam. And chloride ion will reduce to chlorine gas by gaining electron. So, sodium hydroxide is then treated with sodium amalgam. Sodium hydroxide is obtained by treating sodium amalgam with water. And then in this process, hydrogen gas is liberated and mercury is also released. All these metals, they are released in the water, in the solution, in the electrolyte. Are you getting? So there is a simultaneous production. And sodium hydroxide is very important in aluminium extraction, bauxite, in the purification. Second, it is used in the manufacture of soap. We all know very well that soap is the most important, right? It is also used in mercerizing cotton fabrics. And it is used in petroleum refining. Got it? So, what is Solvay's process? Yes, Neil. Are you getting or
Right,
not?
sir. I'm getting.
Second is calcium carbonate. How? Calcium carbonate. How you can obtain this? You have to take a slaked lime. Slaked मतलब क्या है? भीगी हुई लाइन. भीगी हुई लाइन मतलब चूने का पानी. ठीक है? And when this reacts with carbon dioxide को पास किया जाता है and you get calcium carbonate plus water molecule. So this is what? Slaked lime. And excess carbon dioxide when you pass, तो क्या होता है? इसके अंदर में से यूटिलाइज हो जाता है और आपको मिलता है सॉल्युबल कैल्शियम बाइकार्बोनेट, इसलिए ज्यादा कार्बन डाइऑक्साइड नहीं पास करना चाहिए। और फिर कैल्शियम क्लोराइड है, मैंने अगर सोडियम कार्बोनेट में डाला तो मुझे CuCO3 मिल जाएगा और NaCl मिल जाएगा। तो ये एक दूसरा तरीका है जिससे कि मुझे वो मिले। ओके, so these are the two methods of preparation. And when you decompose this calcium carbonate, it forms calcium oxide plus carbon dioxide, which is released. And when it reacts with acids, it forms calcium chloride plus CO2 plus H2O. Mind it, with carbon dioxide, carbonates, you will always get carbon dioxide. Got it?
Got it,
So
teacher.
calcium carbonate in the form of metal, it is used as a building material. It is used in the manufacture of quicklime. So calcium hydroxide, यानी चूने का पानी, that is what? That is slag lime, and calcium oxide is quicklime. And this quicklime, it is major ingredient for making cement. This is neat question. पूछते हैं कई कई बार। और कैल्शियम कार्बोनेट प्लस मैग्नीशियम कार्बोनेट, ये दोनों यूज होते हैं एज अ फ्लक्स, एंड इट इज ऑल्सो इम्पॉर्टेंट इन मेकिंग हाई क्वालिटी पेपर्स। भाई इसके अंदर में ब्लीचिंग वाला काम भी हो जाता है। इवेंट आपका टूथपेस्ट है, आपकी च्युइंग गम्स हैं, ओके, ये सब चीज में भी हम यूज करते हैं। गॉट इट?
Yes, teacher, got it.
नाउ नेक्स्ट इज H2O2, हाइड्रोजन पर ऑक्साइड। अब ये पर ऑक्साइड है, ये ना, इट इज अ वेरी गुड ऑक्सीडाइजिंग एजेंट, इतना याद रखना। इट्स अ वेरी वेरी गुड ऑक्सीडाइजिंग एजेंट। और H2O2 का 30% एक्वस सोल्यूशन है, वो तो अवेलेबल भी है। So how you are going to prepare? See, in this case, hydrated barium peroxide. बेटा पर ऑक्साइड आता है ना, समझ लेना, पर टू। जनरली हम यूज करते हैं Na2O2, H2O2, ठीक है। सो hydrated per barium peroxide, it is treated with thanda sulfuric acid, not cold. And here you will get barium sulfate plus H2O2 plus H2O. And when there is another process that is called as Merck process. So when this Na2O2, sodium peroxide, देखो peroxide means O2, Na2O2, when it is treated with H2SO4, ये क्या देगा? H2O2 plus Na2SO4. So again, it is obtained. And from sulfuric acid also. When sulfuric acid undergoes electrolysis, तो हम क्या बोलेंगे? 50% solution of sulfuric acid. Okay. Now this is subjected to electrolytic oxidation. मतलब हम ना इसको ऑक्सीडाइज करते हैं, इलेक्ट्रोलाइसिस करते हैं, और ये क्या देता है? H2S2O8, और इसके अंदर में 2 इलेक्ट्रॉन्स हमारे रिलीज होते हैं। और ये क्या है? पर ऑक्सी डाई सल्फ्यूरिक एसिड, डाई सल्फर, क्या hydrolysis of peroxydisulfuric acid, it gives us H2SO4 plus H2O. And this is used in the preparation of D2O2 also. Okay. And industrially, hydrogen peroxide is used by air oxidation of ethyl anthraquinols. See, benzene products हैं वो हमको क्या देते हैं? Quinols. And in this case, catalytic hydrogenation occurs and it produces ethyl anthraquinol. Okay, so basically oxidation occurs. What do you see here? Can you name this compound? Yes, Neil. The compound that I am making, can you name it? This is 2-ethyl anthraquinol, which is produced by oxygen. Okay, and it will produce non. Why it is non? Do you know? Neil,
Yeah, teacher.
do you know why it is non?
No, no, I don't.
Because of this. And if you react it back again with hydrogen gas in case of palladium, so it will get converted back into ethyl anthraquinol.
Okay, sure. Just 1 second.
So basically, this pure H2O2, it is very pale blue colored. It is miscible in water. So if it is miscible in water, what we will write? H2O2 dot H2O dot H2O means added with water. And we say that 30% solution of H2O2 has a volume strength of 100 volumes. It means 1 ml. If you take 30% solution of H2O2, just 1 ml, that will give 100 ml oxygen. 1 ml, 30% solution. 1 ml, 30% solution of H2O2 will give what? It will give 100 ml oxygen. Okay, and so H2O2, it acts both as a oxidizing agent and a reducing agent. In oxidizing agent, we see Fe2 plus becomes Fe3 plus. And reducing means MnO4 1 minus plus H2O2 is reacted. It gives Mn2 plus. Okay.
Okay, yes. 1 second,
So
1 second.
what? You're writing?
Yeah, teacher. Yeah, teacher.
So it is used as a germicide. Then it is used as a mild antiseptic. It is used as a preservative. Okay. It has got its mild oxidizing property. Therefore, it is used as a germicide. It is used as an antiseptic. And basically, we are using it as a preservative also. See, you know what is the function of preservative?
It is basically to keep any product, yeah, to keep any product usable for longer.
Yeah, usable for longer, and secondly, it does not get spoiled also,
Yes.
to prevent it from getting spoiled. And it is used as bleaching agent. Bleaching agent for soft materials. Why? Due to oxidizing property. It has got oxidizing property. Hmm?
Okay.
Now, here, because it has got reducing property, therefore it is used as anti-clor. Why? Anti-clor to remove excess chlorine from fabrics. Anti-clor, anti means removal, chlor means chlorine. You know, the bleachings which we are used, it contains it contains chlorine. So if some more chlorine is been added, then what we can do, we can use this to remove it. Okay, so it is again used as an anti-chlor. Now see problem 8.8. Check if you can do.
Okay, teacher. One second. Yeah, teacher. I'll solve.
Huh?
Should I solve or
Yeah.
should I tell you?
No, just check if you can do. Then I will
I
go
can.
ahead.
I
Okay.
can do.
Should
I
I go?
think.
Ah, fine.
Yeah.
I know you can do. Now you have grown tremendously. Very nice. Now next is lithium aluminium hydride. Now this lithium aluminium hydride, now it is basically obtained by treating lithium hydride plus AlCl3. Now this lithium aluminium hydride, it is basically used as a catalyst also. Why? Because you know, they are used to carry out various processes. Okay. And it is used as a reducing agent. Most important use. Lithium aluminium hydride is used as a you can say reducing agent in whatever organic reactions which we are doing. Like you can say OR dash. Now this in presence of lithium aluminium hydride and dry ether, it gets converted into OH plus two molecules of alcohol are formed. So this RCOOR dash, this is what you can see the breakdown. Here it is forming OH and OH, two alcohol groups are formed. Secondly, if we see this, Again, in presence of lithium, aluminium hydride and dry ether, here also you will get alcohol plus water. This is what oic acid. So oic, you know, it is a process that all gets converted into ale and ale gets converted into oic acid, and reverse also follows. From oic acid you can prepare carboxylic, from carboxylic you can prepare alcohol. Got it? So this one is what? This one is oxidizing. Go on adding oxygen, 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 oxygen. You will get oic acid. Then we see that when it combines with PCl3, lithium aluminum hydride, when it combines with PCl3, it produces phosphine gas. This is what? Phosphine gas plus AlCl3 plus LiCl. Now, this is a very important reaction. Oh, we are done with our chapter.
Uh, yeah. This is
Yes.
the last topic. This is the last
Yes.
topic.
Oh. And another chapter is chemical bonding, right?
Chemical. Uh, yeah. Yeah. No.
So
Wait,
now
wait, wait,
you can go, yeah, you
wait.
can go through it. Huh.
No. The only chapters were analytical chemistry and elements of group 1 and 2.
So now analytical chemistry is again very important.
Yes.
Uh, because if we see the actually in NEET it is absent, but this when we are talking about LiAlH4 lithium aluminum hydride, when we are talking AlCl3, when we are talking about LiCl, all that is related. So if you learn in this, your NEET will also be good because they are all used in organic chemistry. Okay.
Okay. Yes. ओके सो ये अभी शुरू कर रहे हैं कि क्या
अभी अभी करना है।
हाँ
बहुत कंची हो जाएगा क्योंकि एनालिटिकल केमिस्ट्री पूरा अलग है। ये एक बार रिवाइज कर लो, कोई डाउट है तो पूछ लो, क्योंकि वो पूरा एकदम ही डिफरेंट टॉपिक है। बाकी तुम्हें जो जैसा करना है करो, बोलो। ओके, एक सेकंड।
नहीं ऐसे ऐसे तो और कुछ डाउट आ नहीं रहा है आई हैव अ डाउट आई लास्ट थ्रू सुष्मिता मैम लेट
हाँ ठीक है। ओके, अब एनालिटिकल टेक्निक्स के अंदर में क्या होता है, सबसे पहले हमको ना व्हाट वी हैव टू डू इज वी हैव टू फाइंड आउट हाउ द प्योरिफिकेशन ऑफ सॉलिड इज डन। सी, अभी कोई भी सब्सटेंस होते हैं ना, जनरली दे हैव गॉट टू टाइप ऑफ इम्प्योरिटीज। ओके, वन इम्प्योरिटी इज द वन विच इज soluble in water soluble, and the other type of impurity is the insoluble impurity. Now this insoluble, you can say, so insoluble impurities there, this can be easily removed by filtration. Okay, like जैसे हम चाय बनाते हैं ना and we separate out. So what you have to do, you have to make a funnel shaped this tissue paper you can take, or filter paper you can take it in the form of a cone. और फिर उस फिल्टर पेपर को इधर रख दिया। ओके, एंड ये पूरा फिल्ट्रेट है नीचे, यहाँ पे ये पूरा फिल्ट्रेट है, डिपॉजिट हो जाता है, और फिर ये इनसॉल्युबल सब्सटेंस यहाँ डिपॉजिट हो जाता है, और ग्लास के अंदर में यू विल गेट फिल्ट। ओके, सो हियर वी आर यूजिंग दिस फनल। ओके, सो बेसिकली जो इनसॉल्युबल पार्ट है, विच जो अंदर रह जाता है ना, एक्चुअली दैट इज कॉल्ड एज रेसिड्यू। ओके, see,
Okay.
filtration is carried out using a vacuum pump. When filtration under suction is carried out, we use vacuum pump. So this vacuum pump is, you can say, a faster and a more efficient system. Okay. And in this case, what we are doing, we are connecting the flask to a vacuum. Okay. By a rubber tube. And then the safety bottle is used to prevent the sucking of the filtrate. Why? Because filtrate can also come. And then we use a special funnel in this case. That funnel, you can see the do you have Coke? That is the Buchner funnel. Now this is another important MCQ for you. That Buchner funnel is especially used in the case of filtration using suction. Okay, and crystals are collected on the filter paper and filtrate in the flask. Got it? Then we see what is crystallization. See, when a crude solid is made of mainly one substance, it has only one substance. Like you make any salt and it has got impurities in it. Now, this which cannot dissolve additional quantity of solute. So what we are saying that a saturated solution, a saturated solution of that crude solid is prepared. Okay, जैसे हम लोग बोलते हैं ना, लोग गाढ़ा कर लेते हैं by adding a suitable solvent. So we get a almost saturated solution. Okay, and in this case, the impurities which are present, they are actually not in high proportion. They are in very less proportion. So first we make a preparation of saturated solution. Okay. Then we process it by crystallization. You make crystals and then it is removed. Then next is by hot filtration. हॉट फिल्ट्रेशन में क्या होता है, ऊपर जो हमने सैचुरेटेड सॉल्यूशन बनाया उसको ना, जब वो एकदम गरम गरम होता है ना, तभी हम उसको फिल्टर कर लेते हैं, और फिर फिल्ट्रेशन है वो कैरी आउट होता है अंडर सक्शन। तो जो भी अनडिजॉल्व्ड इम्प्योरिटीज होती हैं वो बाहर निकल जाती है। ओके, नाउ नेक्स्ट इज फिल्ट्रेशन, कूलिंग ऑफ द फिल्ट्रेट। तो आपका ये जो भी हॉट फिल्ट्रेट होता है ना, जो हॉट फिल्ट्रेट है, वो हॉट फिल्ट्रेट को ना हम पहले ठंडा कर देते हैं, और उसके बाद में क्या होता है कि जो फिल्ट्रेट होता है, एक्चुअली दैट बिकम्स सुपर सैचुरेटेड, that filtrate becomes super saturated, and the excess quantity of the dissolved solute comes out of the solution in the form of crystals. लेकिन जो dissolved impurities होती है ना, they do not super saturate. So you can say super saturation of dissolved impurities does not occur. Okay, because they continue to remain in the solution even after cooling. Then the separated crystals, they become free. Okay, they are free from soluble impurities. And since they are free from soluble impurities, they can be separated. Are you getting? So in the case of, and finally, you have last, that is the filtration. So whatever the pure substances are there, how they are separated. See, pure substances, they are actually separated by the process of filtration. And the filtrate we obtain, that is called as mother liquor. Okay, so the crystals which are formed, they are soluble plus insoluble impurities. Got it?
Yes, for it, teacher.
Okay. Chalo, we'll continue then in the next class. Just go through it, whatever we have done.
Okay, okay. Okay. Thank you, teacher.
Bye.